Hello students, welcome to Abhyas IIT Prep. So now I am going to explain one short method to find the adjoint of a matrix. Okay, we use this concept in finding the inverse of a matrix. Okay, right. First of all, adjoint of a matrix. So coming to the definition, adjoint of a matrix. Okay, the definition is replace the elements with the transpose of the matrix obtained by replacing the elements with their corresponding cofactors. Okay, so this is the definition for adjoint of a matrix. But calculating cofactors, it will take lot of time. Okay, for each and every element calculating the cofactors means it will take some time. Okay, to avoid that there is one smart trick is there. Okay, now I am going to explain that smart method. Okay, here first we know for 2 by 2 matrix. Okay, for example, if I am taking 2 by 2 matrix as like this. Okay, A equals, if it is A B C D. Okay, I am taking 2 by 2 matrix. Now according to the definition, so the definition of adjoint is we have to replace the elements with their cofactors after that transpose. So with that finally we get adjoint of this matrix equals to like this dA. That means we have to interchange these two and keep negative sign for, that means opposite sign for the elements B and C. Okay, this is for 2 by 2 matrix. Same in this concept only we can find the adjoint for this matrix also with the cofactors. But finding cofactor means lot of time it will take. Okay, now I am going to explain one short method. Here the method is just all of you see this. Here I am taking one structure like this: R1, R2, R3. We know R1 first row, second row, third row. Here first I will start with R2. Next I will move to R3. Next I will move to R1. Next again from R1 to R2. Okay, this is the structure. Okay, now we'll see what is the meaning of this structure. Okay, first I will start with R2. Here R2 elements are 1, 4, 3. Now in this also I will take this procedure. That means first I will start with 4 and I will write the elements as column wise. That means 4, 3, right, from 4 to this side, 3, next this side and this side, same structure. Okay, starting from R2 moving to R3 and R3 to R1, again R1 to R2. That means here first I will start with R2 and especially the middle element 4, 3, 1, 4. I am writing it as column wise. Okay, so it's 4, 3, 1, 4. Next I will move to R3. After R2, R3. Now here also same procedure. 3, 4, 1, 3. Next I will move to R1. Here also same. 3, 3, 1, 3. Okay, 3, 3, 1, 3. Again R2. That means 4, 3, 1, 4. Okay, so this is the structure. 4, 3, 1, 4. Now from this structure, adjoint of this matrix is given by, right now adjoint equals simply cross multiplications. That means 4 into 4, 16 minus 9. Okay, 4 into 4, 16. When we are moving downward to upward, we have to take minus. So 16 minus 9, it is 7. Next, 9 minus 12, so it is minus 3. Next, 9 minus 12, minus 3. Okay, so it's same. 3 minus 4, minus 1. 4 minus 3, 1. 3 minus 3, 0. Next, 3 minus 4, minus 1. 3 minus 3, 0. Next, 4 minus 3, 1. Okay, so this is the adjoint of the given matrix. Okay, so this is a very smart method to find the adjoint of a 3 by 3 matrix. Okay, so right, so again I am repeating here the main structure is first we are starting with R2, next we are moving to R3, next we are moving to R1, from R1 again R2. That means we have to write that elements as column wise. Here also 4, 3, 1, 4. Okay, 4, 3, 1, 4. Next R3, 3, 4, 1, 3. Next R1, 3, 3, 1, 3. Next again R2. So 4, 3, 1, 4. We have to write that elements as column wise. After that cross multiplication that is given by the adjoint of the given matrix. Okay, so yes, thank you. Thank you for watching.